Welcome you all to the first lecture of storage system. So in today's lecture we are going to discuss on these topics. Okay, so let us start with the energy storage system. So as you all understand that the renewable energy integration to any power system requires a reasonable amount of storage so that the uncertainty associated with the renewable generation can be protected. So to understand these things, so we understand this by taking an example of solar system. Okay, so in a solar system the maximum energy which is available to you is during the daytime, and not necessarily that your peak energy requirement may fall exactly at the time of peak solar energy production. And during this period, if the load is reasonably low during the maximum generation of peak to solar energy production, then the excess energy available to us from solar may not be utilized efficiently. Okay, so until unless if the system is integrated with huge renewables, and if the grid is hungry to observe all that is available to you from the solar, then it is fine. But if your system is Iceland, it or not able to accommodate the solar energy at a given point of time, then we need to store those available energy from solar so that it can be utilized during the second peak or during the evening hours. So let us take another example which is related to the solar. So we are taking an wind energy. So in a solar energy we have a peak time in the day, but as you all know that in the for the in the wind energy the peak time is the late evening or night time. So in the wind energy the maximum energy available to you is from wind is during the late evening, and as a whole the peak requirement in the evening hours do not fall in the line with your maximum wind energy available to you. So once again the wind energy need to be stored during the midnight. Okay, so that can be utilized during day peak. So as a whole that what I wanted to focus here is, if you wish to integrate maximum percentage of renewable to your grid, and if they are of solar or wind, you need to have storage technology in place so that the investment being made for in renewable integration is being justified. So so now always please remember this thing, that God is not very kind to engineers, and especially for renewables and electrical engineers, because the peak energy requirement period unfortunately do not fall with the peak generation from both the renewable sources, especially from solar as well as wind. So let us focus how this challenge can be addressed by having storage system, and how to model all the issue related to storage technology. So so here and a question which come in your mind, that what is the importance of storage system. So for the importance of storage system, the answer must, you know that in the previous slide I told you that now the first importance is during the renewable energy access as well as in a deficit. Okay, so for this thing storage system is used. So for the importance of a storage system, it is divided in the three part, that is during renewable access deficit, during Iceland mode, and to flatten load curve. So first discuss about the during renewable excess deficit. As you know, in the grid connected mode, battery can store excess of renewable energy when demand is less, and supply the required deficit power when the renewable generation is less. Okay, as whole, what we wanted to say, when the load is high, the battery can provide it, and as the when the renewable generation is getting reduced, and if your load is more, then still the battery can accommodate those excess demand. Okay, so in the second point, now during Iceland mode of operation, in specific to the remote area, grid system access help to regulate the grid voltage by its charging and discharging action. The associate characteristic of the storage system is very important. Okay, it can certainly make your system healthy by appropriate discharge and charging. So action from the storage system. Now one more very important part that we need to focus today is that if the load curve is ideal, not very flat, for any developed or developing country across the world, the load curve is never being flattened. Okay, so the activity, some of the countries do have multiple peaks and some of them have do a minimum number of peaks, but in general we do exercise at least one to two peak during the day, and because of that you need to have access installed capacity to protect or to maintain or to meet those peaks. But during the rest of the day, maybe for 14 to 15 hours a day, you need not efficiently utilize those generation which has been installed or available to you. So it is a very good idea if you can flatten your load curve so that the installed capacity is very close to your requirement peak, and that is one of the most interesting phenomena can be achieved with help of storage technologies. Okay, since both renewable generation and loads are variable by nature. Okay, so the use of the battery can flatten the load curve mean you do your charging action during off peak hours and perform your discharging action during peak hours. So by this we can certainly increase your off peak hours, reduce your peak hours, so that the load curve can be made flattened. Okay, so let us discuss about the types of non-electric storage system. So now there are different types of non-electric storage system that can be need to understand in a given power system. So there is a mechanical storage, electromechanical storage, and thermal storage. Now now first one is a mechanical storage, that is pumped water storage, compressed storage, and flywheel. One of the very common storage scheme today could be of a pumped water storage, where the water can be pumped back to the dam during off-peak hours, so that we can utilize those energy or the water during peak hours through proper discharging. Now, in case of electromechanical storage, we do have accumulators with internal or internal storage. Okay, accumulators with external storage and hydrogen system, and we do have thermal storage, which is hot water to storage. Okay, so let's discuss the types of electric storage system. So so look into the storage system. This is mainly my battery storage system, and you can see the superconducting energy storage. Okay, and finally we do have superconductors also, capacitors also, sorry. Electric storage, most of them are battery, but we can certainly move to superconducting as well as supercapacitor, because they possess not simply store the energy but also perform other technical challenges faced by any given grid. uh, so let us study about the battery storage system. Now the battery storage system improve the reliability to the utility of customers. Okay, because it can provide your energy as when required. Power balance is achieved by this, and both charging and discharging reduces both charging and discharging reduces system loss and improve overall efficiency, because it is locally being supplied, reduce peak electricity demand, and make grid more resilient and stable. Provide ancillary service like fault ride through reactive power and virtual inertia. Okay, now the basic question is, what are the key deciding features of battery storage system? So these are the key storage. So now how do you decide where to place your battery? What would be its magnitude, number of batteries? Everything need to be analyzed before we manufacture. Okay, and put them in a place. It should match with the properties of power system, required storage capacity, minimum storage period, charging and discharging time, required energy density and lifetime, all these things, available location and environmental factor, and minimum number of storage cycle. So those are the factors which are need to keep in the mind during taking decision. So this is all for today's lecture. So thank you, hope you all are stay safe. Okay, thank you.